Okay, so in this video I'm going to tell you how to run the jar file for spectral analysis. So spectral analysis we saw in class is basically using the adjacency list or the adjacency matrix to find the eigenvalues and eigenvectors for a graph. So I would have given you the zip file, one for the adjacency list based computation and one for the adjacency matrix based computation. So if you try to unzip this, just double click on this. I'll get to see all the files inside the zip file for adjacency list. Just copy everything, okay, and wherever you want to run your program, so go there and create a folder. I'll just name it as EVC adjacency list, and inside the folder paste all the files that you unzipped, okay, and that is it. So make sure you do not do any changes to this manifest file. This is a jar file that is basically used for the eigenvector computation. So these are the class files and this is the executable jar file which we'll be using. Now this is a sample adjacency list file which I have given you. This is for a graph with the edges being 0, 1, 0, 2, 1 to 2, 1 to 3, 2 to 3 and so on. So this is an undirected graph, okay. So just double click on this jar file, the EVC adjacency list jar file. It will ask you which file you want to load as adjacency list and analyze. So I'm going to load this adjacency list file here. So I have saved it here. Let me see. Okay, so double click on that. So it will, once you click and open it, it will analyze the file and give you the results. So these are the 8 vertices in that graph. So these are the 8 eigenvalues, and the largest eigenvalue is 3.342, and this is the eigenvector for this eigenvalue, and the eigenvectors are given in the decreasing order of the eigenvalue. So this is the largest eigenvalue and the corresponding eigenvector. So we call as the principal eigenvalue the principal eigenvector. This is the next largest eigenvalue and the corresponding eigenvector. This is the next largest eigenvalue and eigenvector, and so on. Now what you could do is you could save all these results here to a file. So just click on save to a file, and you can basically save it to a text file. So I can say results of the adjacency list file 3.txt. So make sure you give a .text extension. Now you could create another file if you want to. So for example, let me see if I can pull up a file. Okay, so let us use this file. So this is my adjacency list. So make sure in your adjacency list, when you create your adjacency list file, there is no blank line after the last set of vertices. So after this line 3, 5, there should not be a blank line. So make sure there's, if you don't press enter again. So if you press enter, you have done a mistake. So make sure there's no blank line after this last line, okay. So I save it as let us say I want to run it here. So let me name it as just adjacency list one dot text. Here I don't I don't need to say dot text because it is going to save as type dot text. If you have opened it as all files, then make sure you save it as dot text for your adjacency list file, the graph. Okay, so now I can when this application is open, I can now click on open and now click on adjacency list one dot text. It's going to give you the adjacency list results for that graph. So we have for this graph the eigenvalues are negative 1.618, negative 1.473, and so on. Okay, you can also save the results of this. Just click on the save to a file button and you can save it to wherever you want to. Okay, so let me again do one more example. This is a 3, yeah, so 3 5. Now you could press a blank let me try to type it, make sure how to type it. So the way you can do this is 1 tab to 2, 1 tab to 3, 2 tab to 3, 3 tab 4, 3 tab 5, 4 tab 5. So that is good enough. So make sure there's no, if I press down key, it has gone to the next line. So if you want to avoid it, press a backspace and click make delete, so there's no blank line after this last line. So that is very important. Okay, so I can save it as say adjacency list 2 dot text. So now open and analyze that file. So we'll get the results for that graph. So we got it as negative 1.5616, negative 1, negative 1, 1, and 2.5616. These are the eigenvalues and the corresponding eigenvectors. You can again save it to a file. Okay. So this is for the adjacency list. So same thing you can do for adjacency matrix. So unzip the zip folder for adjacency matrix I've given you, copy all the files, we'll create a folder called as EVC adjacency matrix. Okay, and paste everything in this. So I'm going to click on the jar file for EVC adjacency matrix and it will ask you which thing you want to open. So go back to where you saved it. So the adjacency matrix folder and adjacency mat.txt, so it is going to give you the results for that particular graph. Okay, so you can again enter the entries from the adjacency matrix, like for example this. Again, make sure there's no blank line, so click backspace and make sure after this line there's no blank line. So I can save it as adjacency mat1.text, which is I want to say it here. So now we can click open, analyze a file. You can select whatever file you want and you get the results of that file. Okay, can again save to a file, and this wherever you want to save it as a text file. Now, of course, before you do all these things, make sure the Java path is set up in your um, computer. Okay, so I would have sent you a video I posted in YouTube showing you how to set the Java path in a Windows 7 operating system. A similar procedure could be used for Windows 10 also. Okay, and in the Blackboard I have posted a link to this video and link to download these jar files. Also, I'll post a website address that also explains you how to set up the path in Windows 7 and Windows 10 for Java. So make sure you download and run all these jar files after you set up the path for Java in your computer. Okay.